it pretty much is exactly what it sounds like. It's relative. So that means that you are comparing one thing to another to determine the age, to determine the age of whatever it is. Okay. So for relative aging. Relative aging, you don't know exactly how old something is, but comparing it to something else, you can say that it is younger or older or the same age, possibly. Okay. But that's what we're going to practice today and maybe throughout this week. Whereas with absolute dating, and that's what we did last week, absolute dating is where you get a number, you get a year. That rock, this fossil is 167 years, 500 million years. You get a number, okay? Now again, is that number exactly precise or accurate? Maybe, maybe not, right? But with relative aging, you get a number, you get more information, or the absolute dating. What we're going to focus on today is a little bit less accurate, but it's just as important, called relative dating. When you do relative dating, you're going to be talking about younger versus older, or maybe even the same age. Okay? And that's about all you can do, okay, when you're looking at things. We're going to focus on rock layers and fossils, trying to understand whether or not they are the same age or older or younger. Okay. So the first thing that we need to kind of first talk about, I see if something happened, but it's not popping up. So the first thing that we want to kind of talk about is how rocks are formed, because that's important. If you don't understand how rocks are formed, you don't know if they're older, younger, etc. Okay? Because there are different types of rocks. They are formed different ways. So the very first type of rock, and you guys probably have heard of this rock before, is called sedimentary. Sedimentary rock is probably the most common, especially in today's world, today's age, 4 billion years after formation of Earth. Sedimentary is the most common type of rock. It is pretty much exactly what it sounds like. Sediments are settling, okay, and that means water. Sedimentary rocks are formed in water. Water erodes rock material, and it creates sediment like sand, right? Creates sediment like sand. Those sediments will fall down to the bottom, and then more sediment will fall on top, and then more sediment will fall on top. And eventually, between all the sediment and all the water, you get a bunch of weight pushing down on those sediments, and they will undergo what's called concretion, or basically concrete concretion. The sediment turn into stone. And in that process, one of the most common is sandstone. So if you play Minecraft, probably heard that before too. But sandstone is a type of stone where sand has been sedimentary concreted into a stone. But there are lots of different types of sedimentary rocks. And the one that you guys probably do know, they do crumble. They are a little bit more fragile, so to speak, because they are just a bunch of little pieces of sediment that are fused together to make rock. Okay? Sediment require water, require lakes, ocean, those type of things. Okay? All right. The second type of rock is igneous. Igneous rock. Igneous rocks are things that have melted and fused together to harden into a rock. Now, everybody thinks that igneous has to come from magma or from a volcano. That's not necessarily true. Any type of melting, whether it's human caused, we can make igneous rock, or if you have some kind of impact, like an asteroid or a meteor, that can form igneous rock because of that heat, that friction, that impact. Nuclear weapon can form igneous rocks when you explode a bomb on them, and they have. We've collected this before, okay? Obviously, nuclear weapon ones are very rare, kind of. You know, we've released more nuclear weapons than you probably think of. As far as testing them and exploding them, there's been a whole bunch of them. So yeah, but any rock that is melted and hardened is an igneous rock. Most commonly, it is from volcanoes and magma. Okay, that's called volcanic rock or lava rock. But it could be from any high heat event. Okay. Now, the thing about igneous rocks, okay, is that igneous rock can form at any layer. Igneous rock can form at the bottom where the magma is. But igneous rock can also come through the ground and form on top. You know, if you think about a volcanic activity. So igneous can form at any place. So you need to be able to identify what type of rock is that, what happened. Okay? Maybe there used to be a volcano, it formed rock, but then it got covered underwater, and then it started doing sedimentary. And again, you got to kind of be able to understand what type of rock it is, understand the history of the place, of the area. And then the last one is metamorphic. Metamorphic is a rock that changed over time due to temperature and pressure. So again, the rock below us is really thick, it's really dense, it's really heavy. And so as those rocks push on each other and you have pressure and temperature, it can change, it can change the limestone, change the sandstone into a different type of rock with high heat and high pressure. Common examples of metamorphic are things like marble. That's a really common one that you guys probably have at home. Granite countertops in your sink, those are metamorphic rocks. Metamorphic rocks are very dense. They are very solid, for lack of a better word. Okay, they're very hard rocks because they've been pushed together with heat and pressure. Obviously, this whole thing is called a cycle. You probably heard of rock cycle in middle school, but the sandstone or the sedimentary can turn into metamorphic. Metamorphic can melt, come back up as igneous. The igneous could erode, could erode away, turn into sediment. That sediment turn into sedimentary rock, blah, blah, blah. The rocks can go from one to another, especially since they are melting over time and recycling themselves. So we have this whole idea of the rock cycle. But again, understanding the type of rock you have will give you an idea of the age and also give you an idea of the history of that particular area. Okay? All right, so a little more about relative dating. And the rules for relative dating are pretty common sense. They're not, and we do call them laws, geology laws, because they're pretty common sense. Okay? So the first rule is the law of superposition. And that's actually one of your note things on there, and I gave you a picture. It's the law of superposition. Superposition just means that the ones on bottom are the oldest, and then the ones on top are the youngest. And again, that should make sense. Okay? In a regular layering of rocks, you're going to have a base, a foundation, but the new rocks are made on top of that. Or the new rocks are made on top of that. And new rocks are made on top of that. Okay? So if you have a straight up layering of rocks, nothing weird in the story, oldest is going to be on bottom, and the youngest is going to be on top. Law of superposition. Okay? So the question is, what if they're not perfectly flat and straight? And that happens quite often, especially on the rock that we are standing on. Okay? We have hills, we have mountains. What if they're not perfectly flat? Well, it's still the same idea. Okay? If they're not perfectly flat, oldest is in the middle or lower in that hill or on the center of the hill, and then the younger stuff are going to be on the edges of that hill. And rock can get turned and bent and folded. And all that to do with the geography, all that to do with the plates hitting each other. The land can get pretty messed up, pretty crumbly. I don't know if you see that picture very well on your note. But there are, especially when we cut through highways, we cut through hills, cut through mountainsides, you see some pretty interesting layering stuff going on. Okay. This is a really famous one. I think it's in Pennsylvania or Maryland. Every time I go to Washington, D.C., I drive through there. And I decided to take a picture of it one time, but really famous mountain. I think it's called Red Hill Mountain, or Red Hill, something like that. Okay. But it's not always perfectly flat. But again, it's the same idea. The ones down here are older, and the ones up here are younger, even though it is diagonal. Okay. It is possible for land and rock to flip upside down. That is some serious folding. That is a serious earthquake. That is a serious meteor impact, whatever it is. Okay. But again, if you get a meteor impact and it flips the rock upside down, that is possible. But again, that's a very isolated event. The rest of the rock around it is going to be normal. Okay. So it's a very isolated event. If you see something like that happening, you can compare it to other rocks and say, okay, something happened here 1 million years ago, 10 million years ago, or yesterday. Okay. You can kind of figure that out. All right, the next one is called the law of originally horizontality. Okay. Law of horizontal originality. This is pretty much also what it sounds like, that rocks are originally horizontal. Okay? Whether it's igneous, metamorphic, or sedimentary, doesn't really matter. Gravity makes the layers horizontal. Okay? If I have a magma tube that comes up through the floor, the magma is going to lay horizontally. Right? Think about a flood. If I had water come up through the floor, water is going to cover the floor horizontally. I'm not going to have water just sitting right here. Okay? It will go horizontally across, because of gravity. Same thing with sediment. If you have sediment that are in water and they fall downward, they're going to fall horizontally and evenly due to gravity. Okay? So, if they are not horizontal anymore, that event must have came after they were horizontal. So if you have them on a slant, if they are bent, if they are broken, if they are melted, okay? If something happened to make them not horizontal, that must have happened later. Okay, it must have happened after the rock was formed. So for example here, this is a crack in the earth. That is what we call a fault line. And we talked about that last week, okay, where the plates meet and stuff creates a crack. That is a fault. Especially if you get an earthquake, the land can shift, the land can go suddenly up, suddenly down, things like that. It's especially common around facing earthquakes and volcanoes. Okay? The picture D is a dog. That is a lava tube. It had melted its way through the rock. Right? You see that? It melted its way. We also call this cross-cutting events. They are cutting the rocks. Okay? Note that D has gone all the way through the rocks into the surface. But there is no D laying horizontal. See, the D is not horizontal? That must mean that D got eroded away, whether by wind or water or whatnot. Okay? All right. So these are called cross-cutting events. So, real quick little activity, little check here, and you guys at home can type it in the boxes if you want. So, can you put these events in order? And let's go from, just list them, but list them from oldest to youngest. What happened first, and what happened last? So, work through it real quick. Give you guys about a minute. Okay. Kids at home can write down in the box which one came first, which one came later. All right, kids on the computer, give me some answers. Anybody want to give me answers here?
C, B, A, D, E.
All right, so C is oldest. Well, it's not over here. But C's not over there on the right-hand side. Where is it? It's below the picture, right? Or maybe it got melted by a volcano or whatever else, right? Okay, we don't know. It's not there. But yeah, it's on the bottom of here. So C is the oldest, thumbs up. But then B and A, the rocks are there because they all got cut and they all got broken. So C, B, A. And again, why? Because B is on top of C, A is on top of B. All right? The law of superposition. All right, so then which one happened next? Okay. Then the lava tube happened next, right? But then the fault broke the lava tube. Right? And so it is on your slides if you guys are interested. Just highlight that area, and I'll have to give you the answers on it. So. All right. So the last, I think it's last, but one of the last ideas is this term called uniformitarianism. Okay. Uniformitarianism. This one is not really considered a law. This one is more of an assumption, but an assumption that scientists are okay with making. Okay? And I have to put that out there because this idea is something that other people argue about, but not really scientists. Scientists are okay with this idea. The idea of uniformitarianism is that things that are happening today happened a million years ago. And things that happened a million years ago happened a billion years ago. Okay? It is this idea that history happened, and it happened the same way. Okay? So if things are eroding today because of water and wind, they probably eroded away a million years ago, the same exact process, right? If mountains were created today, they were probably created the exact same way a million years ago, okay? We were not there to prove it, but science is like, yeah, that makes sense, okay? So we have this idea that rocks change by normal processes that happen throughout history. Okay? Now, if something does not fit that pattern, we have to explain why, what might have happened there. So I just said an example earlier. It is possible for rocks to flip upside down. Scientists are going to have to explain that, though. What happened? Was there a meteor impact? Did an alien land there and flip the land upside down? I mean, what happened? Well, that's not normal. So something had to have happened. We need to look for other evidence. And things you're going to be looking for there are massive earthquakes, a massive impact event of some type to flip that land upside down. Okay? And hopefully there is evidence of that. Okay? So this is a really important idea that scientists all kind of agree on. But this is also a little bit of an area where non-scientists pick at a little bit. Like, well, how do you know that happened in the past? Well, we don't really, okay? We weren't there. And we never will, okay? But again, it's also Occam's razor. Occam's razor, if you guys know that idea, the simplest explanation is often the most correct answer. Why did that happen? Water probably eroded it away. How did the Grand Canyon form? Probably water. Colorado River, which is at the bottom of the Grand Canyon. Okay? So again, you have to kind of go with what makes sense and what is currently happening today. Use data to back that up. All right. So rock can change quite a bit over time. Remember, they are normally layered horizontally, but they can get eroded away. So for example, look at picture B. Good idea of how a canyon is formed, or how Red River Gorge is formed, which is kind of a state park in Kentucky. Okay. Probably water used to be there. Not there today. The water probably used to be there, and it eroded away. Or that was a massive earthquake that cracked that land and moved it apart from each other. Okay, it's probably water though. Probably water erosion. There used to be a river. The river dried up, and now there's land there. Okay, so that makes the story make sense. Okay, especially along the ocean edges, probably water, probably air, probably wind made those rocks go away. Right, and so erosion can make a very interesting story. If you ever been to the Grand Canyon, you probably know that that's a lot of erosion. But erosion is also very, very powerful. It's a very, very powerful force. Water and glaciers and ice, that can cut through rock really easy. Okay. All right, so today you guys have a couple of challenging problems. They're not too hard. But on your worksheet, a couple of vocabulary definitions, and then taking a look at the age of events that happened using these ideas. If you need more resources, I highly encourage these resources. You guys are going to watch a video on Wednesday that is really good. The guy does a much better, he's a teacher apparently. He does a much better job than I could or can do. He's got really cool animations and graphics, and he teaches them. It's not just for fun. He does a really good job of explaining the animations and what happened throughout time. So Wednesday, you can watch a really good video, and that's just going to be your lesson on Wednesday. So it's going to be really simple, really easy. So let's pop up that handout real quick. Let's take a look at it. Worksheet. Found here. So your first picture, about a family, right? Let's see here. Let's share the new screen. Let's share this one here. All right, so this is a picture. Let me put it over here so a kid can see it. All right, so this is a picture of rock layers, and a very common picture looks just like this. We can actually tell the story of what happened to this place. So the very first thing we're going to do is the laws of superposition. That's going to be the most basic. Which one came first? One on the bottom. Okay. So this hilly event happened first at the bottom, and it was originally horizontal. Okay. But they all layered each other. So we got the sandstone happening first, the conglomerate happening second. By the way, conglomerate is not really a rock. It's kind of like concrete or cement. It's kind of a mixture of rocks that have to harden over time. You'll see that word a lot, conglomerate. Okay, but it is a layering of rock. It's kind of like a metamorphic, but doesn't have to be. Conglomerate could be any type of rock. It's a collection of rocks that are kind of hardened together. So a conglomerate, and then we got a shale layer, and then we have a limestone layer, and then another shale layer. But look what happened there. Now we have a limestone and shale on top. Something happened before this limestone though. Okay, we probably have an area of uplifting. Uplifting it brought the rock up and it turned it into hills and kind of messed up the rock when it did that. Okay. We also have some erosion. Do you see the erosion where the layers are not really there anymore? So this lifted the rocks up, but then we have erosion happening right in between those layers. And hopefully you guys at home can see what I'm talking about. So there was erosion. Note that the rock on top is sedimentary, which means that this land was once underwater. It layered, went above water, got hilly, eroded away, and then it went underwater again and formed new layers. Not only that, look at the top layer. It's eroded away again. So it must have gone back out of the water for erosion to happen, whether it's water, air, wind, ice, whatever. The only way erosion can happen is if it's exposed and air, water, us, humans, cut it away, things like that. So again, you can tell the history of these places of what happened there. Okay? All right, so I just gave you the answer to the first one there. Okay, this one's pretty simple. As you go down though, that one's really simple too. Okay. As you go down here, I do want to talk about this one real quick before we leave here. This picture here, these are all the same place, the same area. But there's different times in its history. So I'm asking, what's the story? Which one came first? Which one came second? Which one came third? And again, looking at the event, looking at what happened, okay? Did it get cut? Did it uplift? Did it fold? Did it erode away? You know, what event happened first, second, third, fourth? So again, they're all the same picture here. Okay? I think you all know what the first answer is, right? Which one came first? It's all horizontal, right? So B came first, and then cut. No cut. Okay, so probably F, right? And then it got cut, and then it got melted, and all that good stuff. All right, so you have a couple of really simple passage problems there. Just make sure you're thinking about the process. Make sure you can explain why A comes first and B comes second, etc. All right, so good night's sleep, a good breakfast, and make sure you're in my room ready to go at 8 o'clock tomorrow. Preferably earlier. Preferably come early. Okay? Be ready to go. I would bring your backpack. I would bring your laptop so that you can work after the ACT. I would bring all that stuff, okay? But for that time, just kind of hanging out. All right, we still got about 90 seconds. So kind of hang out, chill. We'll get going here in a couple minutes.
Mr. Cam. So, I was told that you were helping us out with the history professor.
What's that?
I just heard that you were helping us out with dealing with the history professor.
Yeah, a little bit. What's up?
She sent us this announcement that's extremely long, and she's yelling at us for making her take too long with it. And there's just a lot of rude and condescending stuff in this.
I think we covered.
Yes. She's basically blaming us for the reason she took everything too long, and I'm gonna have to redo my entire paper because she didn't explain it well enough.
Do me a quick favor. Can you do a screen capture?
Yeah.
And then can you email me that? I'm not real happy with you guys are good to go. You guys are good. Have a good day. See you later. Yeah, I'll look at it and I'll talk to some people. If you haven't yet, if you're talking to Steve, let him see what you're doing.
Yeah.
Okay.
Thank you.
All right, guys, I haven't sprayed down tables yet.